Hello everyone, I'm Typhon and today we are diving into process of setting up your SDR receiver and selecting it as a source in SDR++. So if this is your first time using SDR++, don't worry, I will walk you through every step, explain why things work the way they do, and throw in a few tips to make the process smoother, whether you are using Windows, Linux, or Android. By the end of this lecture, you will have your SDR receiver ready to explore the world of signals. So, let's get started with the first task, installing your SDR receiver. These devices, often called dongles, are small but mighty tools that let you explore the radio spectrum from FM radio to air traffic communications and beyond. Why you need to know about SDR compatibility? SDR++ supports a wide variety of SDR receivers, and the setup process is usually straightforward. However, every receiver is a little different. Now, here's what you should know: drivers first. So, before anything else, you will need to install a appropriate driver for your SDR receiver. Most manufacturers provide these on their websites, so look there first. But in this case, of course, SDR has pre-installed drivers as well, like the DLL files. Here you can see the HackRF, libUSB, and so on. So in the 90% of the cases, you don't need to install uh, drivers if you are with SDR++. And if you don't have the driver, once the driver is installed, connect your SDR receiver to your computer, and SDR++ should recognize it automatically. But don't worry if it doesn't, we will troubleshoot that in a moment. Here, you can see I have HackRF connected here. So there's a special cases to consider. For Linux users, Linux has built-in support for many SDR receivers, but occasionally you will need to install additional modules or drivers. So if your receiver isn't detected, if your receiver isn't detected, try adding support through SOAP SDR, for example, which this SOAP SDR acts as a middleman between SDR++ and your hardware. So you can do like SOAP SDR, no, sudo apt install, sudo SOAP SDR, sudo if you are using the RTL-SDR like that. But if you are using the uh, HackRF, so the apt install HackRF. So this will install the Linux drivers for your RTL SDR receiver or other SDR receivers here. But of HackRF, by the way, HackRF is also a transmitter. Now, for the to check if HackRF is works, you can write this command after installing, and this will show you information about HackRF drivers and the device here. Now you can also, as I said, check the manufacturer's website. For example, some advanced receivers like AirSpy or SDR Play might need their own configuration tools or special drivers. Always check the documentation provided by the manufacturer here, and this is their websites if you have one of this. But in this case, we will use HackRF and RTL-SDR. Now, if your receiver isn't working right away, don't panic. Double check that you have installed the correct drivers and that your operating system recognizes the device. And here, as you can see, Universal Serial Bus devices, I have HackRF 1. And now let me connect the RTL-SDR right now. Here. device manager. Now it should be somewhere here, but it might be unrecognizable like the balcony interface. This might be it. But the thing is, the SDR++ will still recognize our RTL-SDR. And here you can see no serial, generic RTL-2832 UOM here. And also let's connect. I have another RTL-SDR, the one in their official website, rtlsdr.com, V4, model V4. You can see the picture. And here now I have connected 3 SDR devices. Click on refresh. Run. You can see I have 2 RTL-SDR devices and 1 HackRF. Now let's connect my another HackRF. And here I have also connected my other HackRF. Now let's click on refresh or open SDR++ again. Here. Now you should see it. Now you can see they have different IDs. Here they both work. And here we have successfully connected 2 HackRFs and 2 RTL-SDRs to our SDR++. And now that your receiver is connected, you can start and do everything with your SDR++, your gateway to the radio spectrum. Now, SDR++ work on multiple platforms, as you learned that in previous lectures. So if you are using SDR++ on Android, make sure to connect your SDR receiver before opening the app. So unlike the desktop systems, Android doesn't allow the application to detect new hardware after it's already running. And for Windows, Linux, or macOS users, if your SDR receiver isn't plugged in when you start SDR++, just click the refresh button and the software will scan for connected devices. And to launch SDR++, on Windows, you can locate the SDR++.exe file in the folder where you installed SDR++. This is actually SDR++ is just like a portable application, so you don't need installation process for this. You can just unzip it and get started by working. But you can also open the folder after unzipping and choose the SDR++ SDRPP.exe file in the folder. And on Linux, you will typically find SDR++ in your system application menu after installation. And here you can go to open terminal, SDRPP, and it will start here. And you can also go to system application and write SDR. And here we can also run this from here. So what happens when you launch SDR++ for the first time? So when you open SDR++ for the first time, the interface might look overwhelming, like there's so many things to control here, but don't worry, that's normal. For now, we are focusing on just one part for this lecture, which is the source menu, which is where you will select and configure your SDR receiver. So with SDR++ open, the next step is to select your SDR receiver as a source. this tells SDR++ which device to use for receiving signals. Now look for the source module tab in the main menu. So if you don't see the menu, click on the small icon in top left corner to toggle it on. By default, menu is located on the left side of the interface. And now click the drop down menu in the source module. Now look here for receiver in this list. So you will usually see its model name like RTL-SDR, HackRF, Blade RF file. You can also use the file that we did in previous lectures. So if you don't have an SDR here, you can use the file. And here, yeah, we have Herm, Slime SDR. We can also use the network, Pluto SDR, RF space, RTL SDR, which was and the most important, the RTL SDR and HackRF is here. And if you don't have the SDR at hand, I strongly suggest you to buy one. But there's still another option. You can use the file. Now you can download the WAV files from internet that's pre-recorded SDR images, and click on this, open, and here you can see we can see this spectrum. So you can play with it if you don't have an SDR device at your hand. But luckily we have one, and not one like I have 5 SDRs for this lecture. And if your receiver doesn't show up, hit here, let's actually set RTL-SDR. Now, if your receiver doesn't show up here, hit the refresh button to rescan for devices and double check that the driver is installed correctly and that receiver is securely connected. I have 2 HackRFs. Let's see, system devices, and so on. Yep, here. Now, here, let's actually open the SDR right now, select our SDR receiver, whether it's a RTL, SDR, HackRF. Now let's go with RTL, but yeah, I have the antenna on HackRF, first HackRF here. So we will choose the HackRF. Broadcast, shortwave broadcast. My mouse again. Here. You can see there's a names for the each spectrum. Here. Now we are in the FM broadcast. Here, let's zoom in. Here. Minute. Yep, that was it. Now, here you can see I have 2 HackRFs connected. Now, let's listen to FM broadcast. I will actually disconnect other SDR devices. And now I have disconnected other SDR devices. Now, we have just one HackRF and one RTL-SDR here. And our source tab should be updated. Here I have just one HackRF and I should have one RTL-SDR here. Now, before wrapping up, let's take a closer look at the source menu and its options. Now, the source menu adapts to the SDR receiver you are using. For example, an RTL-SDR dongle might display different options than HackRF. Here, you can see it displays different options, or an SDR Play device. So some options in the source menu are only available when SDR++ isn't actively receiving. You see here, it's grayed out. If a setting here, like this, is grayed out, simply stop the receiver, make your changes, and then restart it. SDR receivers provide various methods to control the gain applied to incoming radio signals. Now, the available options include main gain control, automatic gain control AGC, or combination of both. Understanding how to configure these settings is essential for optimizing your signal reception. Now let's delve deeper into each aspect to get a more comprehensive understanding. Manual gain control allows you to adjust the gain manually by increasing or decreasing the amplification applied to the signal. This setting is crucial for fine-tuning your reception quality and is particularly effective when dealing with a variety of signal strengths. The gain is measured in decibels and is typically adjusted using slider or a control bar. In SDR software, for example, you can drag a blue bar to the right to increase the gain or to the left to decrease it. Let's actually increase our saturation a little bit, and here. Now our gain is increased, decreased. Now get started by initial setup and begin by tuning to a strong and clear FM broadcast signal. Now let's get started. And also, by the way, if your audio is grayed out, simply click on the enable the checkbox on the right of the radio box, and you will hear the audio. Now, now let's begin by tuning to a strong and clear FM broadcast signal. Now we will adjust the gain until we achieve a signal that is free from noticeable hissing or static. Also increase this a little bit. And yeah, like this, low pass enabled here. Now, interestingly, reducing the gain rather than increasing it can sometimes improve signal clarity. This happens when excessive gain amplifies unwanted noise along with the desired signal. So, as you gain experiments with your SDR receiver, you will encounter weaker signals. Adjusting the gain for these cases requires a bit of patience and experimentation. Focus on achieving the best signal to noise ratio, SNR. So, which is the balance where the desired signal is much stronger than the background noise. This adjustment is particularly useful for decoding faint transmissions like amateur radio and distant broadcasts. Additional control. So some SDR receivers also offer an intermediate frequency IF gain control. So this setting adjusts amplification at a different stage in the signal processing chain, allowing for even finer adjustments. Experimenting with IF can help you overcome specific challenges, such as strong nearby signals that interfere with weaker ones. So automatic gain control simplifies the signal adjustments by dynamically balancing the signal levels. This is especially useful when the signal strength varies frequently, such as during mobile operations or when monitoring changing frequencies. So the AGC system, the automatic gain control system, automatically amplifies the weak signals while reducing overly strong ones to ensure the output remains within a comfortable range. This reduces the need for constant manual adjustments. So depending on your SDR receiver, you might have several AGC settings. So for example, fixed levels, devices like AIRS by HF Plus discovery provides preset automatic gain control levels, off, low, high, like that. So allowing you to select how aggressively the receiver balances signal levels. And advanced SDR receivers may allow you to specify parameters like attack and decay times, giving you a greater control over how quickly automatic gain control responds to changes in signal strength. And keep in mind that enabling AGC often disables manual gain control. So choose the mode that best suits your use case. AGC for dynamic environments and manual gain for precise tuning. So the sample rate also we need to consider is the sample rate. Sample rate determines the width of the radio frequency spectrum that your SDR receiver can process and display at any given time. This parameter significantly influences both performance and usability. Now you can see here we can also set the sample type and container radio and so on. And high sample rates, as you learned in previous lectures, devices like the SDR Play RSP1A can display up to 10 megahertz of spectrum, providing a wide view that's useful for monitoring multiple signals or identifying signal patterns. And lower sample rates, devices such as AIRS by HF offer narrower bandwidth, such as 768 kilohertz. While this might seem limiting, it often improves performance by rejecting strong, unwanted signals from nearby frequencies. So, the higher sample rate demand more processing power and may cause glitches or interruptions on less powerful computers. So, if you experience performance issues, reducing the sample rate can help, can may offer like stabilize your system. And for instance, the RTL-SDR dongle typically supports, this RTL-SDR dongle typically supports up to 2 megahertz of sample rate or bandwidth, which is sufficient for most hobbyist applications. In contrast, professional grade devices may offer much higher rates for advanced use cases. Now, also we need to consider the compatibility here. So, not all sample rates listed in SDR software are supported by every SDR receiver. Always refer to your receiver specifications to ensure compatibility. Bias T. A bias T feature allows an SDR receiver to supply power through its coaxial cable to an external RF amplifier or active antenna. This capability is indispensable for enhancing reception in setups that require additional amplification, such as long distance HF or VHF, UHF operations. And before enabling BIOS-T, consult your receiver's manual to confirm compatibility and power requirements. So ensure the attached amplifier or antenna is compatible with the receiver's BIOS-T specifications and verify the receiver's BIOS-T provides adequate power for the external device. Using an incompatible setup can damage your SDR receiver or connected equipment. So, by understanding and effectively managing these features, manual gain, AGC, sample rate, and bias T, you will be well equipped. You will be well equipped to optimize your SDR receiver for a variety of signals and operating connections and conditions. And now let's dive into a neat feature that can significantly expand the frequency range of your SDR receiver can handle: offset timing. Essentially, you can use additional hardware to shift a specific range of frequencies into the SDR receiver's accessible range. To activate or deactivate this feature, you just need to check or uncheck this offset timing box once you have set the correct offset mode. So we don't have the antenna for RTL-SDR. Like I haven't connected antenna for RTL-SDR, so we will go back to HackRF. Yeah. And yeah, now, for example, we can also consider the practical example. Like, let's say your SDR receiver is designed to cover VHF from 30 to 300 megahertz and UHF frequencies 300 megahertz and above, but you're interested in listening to HF from 3 to 30 megahertz, or MF from 300 kilohertz to 300 megahertz. So this is where a converter like the Hamitop comes in handy. It's an up converter that raises the frequency of incoming signals to match the SDR's range. So for example, it shifts signals by 125 megahertz. So if you want to listen to 7 megahertz signal, you'd tune to your SDR to 132 megahertz. But of course, you want the display to show the actual 7 megahertz frequency you are listening to, right? So to make that happen, you will need to select the appropriate converter type in the offset mode settings. For HackRF, we don't have the offset mode, but for RTL-SDR, you can say offset tuning. Now, there's available converters for these offset modes like SpyWorder, Hamitop, DKey 5AV X-band converter, Q-band satellite, LNAs, and which used as down converters. Now, let's talk about IQ correction. Now, let's talk about this IQ correction here. So, this is an important setting that helps fix issues with your SDR hardware that might cause unwanted effects, like the DC spike on the frequency display. It can also help with imbalances that impact things like audio quality or data reception. Now let's go back to HackRF and enable IQ correction. Disable it, enable it. Now you see the spike here? So this helps with the DC spike appearing on this frequency display. It can also help with, as I said, imbalances that impact things like reception and audio quality. And to adjust it, you simply tweak the value until the spike disappears or moves outside the range you are tuning to, called VFO's passband. And next up is decimation. So you actually learned this decimation in our previous lecture, but this setting basically reduces the number of samples taken from the incoming radio signals. A radio decimation of 2 means the SDR takes one sample every 2 incoming signals, while 4 means one sample for every 4 signals, and so on. So you have actually learned that decimation in our previous lecture. We have separate lecture about the decimation I captured here. So if you forgot, I suggest you to watch that lecture again from beginning to end. So to summarize, offset tuning allows your SDR receiver to cover a wider frequency range. IK correction fixes display and signal imbalances, and decimation helps optimize your SDR's dynamic range, but with some trade-offs in frequency width and signal quality. Adjusting these settings carefully can make a big difference in your SDR experience. My name is Typhon, and I'm waiting you in next lecture.